Hello and welcome to this new video. Today I'd like to show you again some RF chart recordings from a customer, and I'd like to give you my thoughts about what I can see in the data and what the graph will show us. Okay, as always, you open Wireless Studio and you go to the RF graph analyzer, you open, go to the folder you like where your files are in. And by the way, these files are recorded during a session with Wireless Studio. And if you close Wireless Studio asks you if you like to save this. And it saves every time on a different folder with all the dates in when it's recorded, at which time, and so on. You select all files you like to show, and then say open, and it's open in the RF chart analyzer. Let me change some parameters here. First thing I always do is go from RF level, average, maximum, and minimum level on the diversity side. I go to detail view and I switch on individual minimum for the two antennas. This is a two antenna system, so we need only antenna A and B. And then I switch off the alert list, and I also switch off the mark list. We don't need this to see more from the data on the screen here. And yeah, maybe we zoom in a little bit. Let's see what we have here. So this is now around 10, 20, 30. This is around an hour here, what we can see, and that's what is recorded. Yeah, that's the first channel. Channel number 1, 534.750 megahertz. And very, very low RF level. I mean, really. And one antenna is always 10 dB or more lower than the other one. And you see that the green antenna here, which is the branch B, the branch A, sorry, is always lower and has more times where it loses the connection complete to the data. Let's look in a little bit. So let's get closer here. Yeah, so what's going on here? The antenna is on 50 dB, the 50 dB microvolt. This is half of what the receiver can handle. So still, again, a very low RF level. I don't know. I see this if the antenna is 50 meters away, but the other antenna has massive drops. So I think these antennas even has even a bigger distance to the transmitter. And then you see that so the antenna is going down. The antenna A, the red one, is going down to 20, and 20 dB signal noise ratio is the minimum the system needs to find the bits and bytes in the data stream. And then you have a drop. It's going down to 60, so I think this drop is a small one, which is not audible. I don't know, but normally if it's between 80 and 60, it's not audible. It's only audible if it's bigger or wider, and if it's deeper. As deeper it is, as more data you have lost. And of course, if you lose, let's say, packet 100 and 200, that's easier to handle for error correction than if you lose package 1, 2, and 3. So 3 packages after each other, or package 1 after each other. This is more difficult for the error correction than if you lost over time always only 1 package or 2. Yeah, that is as it is. Let's go forward and see always, yeah, very, very, very low antenna level, and still okay, so no drops. That's perfect. Here it's much better, so that it has to be between 60 and 80. That's always fine. And here again, the B branch is very, very low in level, and then we come to a point where we have another package loss, which is, again, from my point of view, not an audible drop. And here the level is always very, very, very low. Again, here both antennas go down, and then you have a drop, which is, this drop will be audible. It's less than 60. It's go down to 40. I think this drop is audible, and then it stops. So that was where the body pack was switched on. Channel number 2, zoom out a little bit, and we have more or less the same situation. Yeah, the antenna level is quite low. Here the antenna is, I think, laying down on a desk, or the artist is sitting on a chair and is doing nothing, so no movement from the transmitter, but still very low level. And sometimes the antenna B branch again is very, very low and drops down to 0. Channel number 3, again, I think this channel was only a short time in use because over this time here it was laying down on a desk or it was not moved. Channel number 4, maybe the same. Here's a little better in the end, but still the antenna B is 10 dB lower in level over a long period of time. Here it's vice versa, antenna number A is low. We don't know what happens. I don't know the show, I don't know the stage, I don't know the setup, I don't know the antenna position, I don't know the gain structure, I have no idea. I just have these RF slides, these RF recordings, that's all what I have. But again, most of the time the antenna level is under 50 dB, so very, very low. Whatever happens, I don't know. And I don't know why. Here again, that's for the whole time it is fine, even the antenna level is low, but there we have, I think, 2 audible drops and 2 non-audible drops, is as it is. This is again, I don't know what happens with the antenna. It's always very low. Here it's the A branch, but it doesn't look really nice. Normally it looks better and it looks different. Here I think the maybe the body pack was not moved over a long time. But again, one antenna is, here it is more than 10 dB, so 15 to 20 dB lower the whole time where the body pack was used. I don't know what's going on with the antenna system, so something is not perfect here. Here again, system was moved on stage, antenna level variates in a wide range, that's okay, and then we have 2 drops, which I guess one is audible, the other not. Here again, very, very low antenna level over the whole show and so on. And let's go forward, and I think there is one the customer told me, which is I think number 13 or was it 12? Now that's the same, 12, 13. Ah, here it is. So this is really crazy. You see the green line is your quality level. So the green line represents the quality of the data, the raw data stream. So is before the AD conversion happens and before the sample rate conversion happens. So it's the raw data stream. And here we see it's always very, very low. It's on 50%. And it is only a small time where it was good. What I find out after some discussion is that the customer cuts the antenna. He says the artist was not happy with the length of the antenna, and he measured the frequency and calculated how long the antenna has to be for this specific frequency they use, and then he cut it. Don't do it. Never do this. This is complete wrong. An antenna is a dipole, so it's this part and the metal case, which is the ground or the reflection. If I understand it correct, I'm not an RF engineer, but from my understanding is that both parts are necessary and both parts together are the antenna. So this length is not calculated only in the frequency, because this transmitter can handle 144 megahertz overall. It's calculated with the dipole, which is the second part of the antenna, is the metal case of the body pack here. So never do this. Never cut antennas. There are antennas on the market. I know you can buy this, you can measure the length, you cut it, and that's fine. But the Sony antennas are not made for this. Don't do this. The other point, what you can have is, if your cut is not perfect, then you get reflection inside the antenna cable, which go back into the amplifier. And that's what happened here on my point of view, from my point of view, what we see on the screen here. So reflections go back and produce interference inside the antenna amplifier. Yeah, the system has an isolator in. Sony is using isolators since a long time, which isolates frequencies from the other part of the spectrum. So the isolator gives you the chance that you can do this. Both antennas will come close together, and they are not pushing each other the frequency into the amplifier and gets interferences. But this isolator will not work on the same frequency where the body pack works. Yeah? So if the antenna is not cut perfectly, if something happens with the antenna, then you get reflections back into the amplifier, and then you see exactly this, what we have here on the screen. So never, I can only talk for Sony antennas, never cut the antennas. That's not helpful. It will give you a very bad quality level and a very bad audio level. Okay, so channel number 13. And then we can look into the other ones, and they are more all the same. Antenna level is very, very low, and one antenna is 10 dB lower than the other one. Mostly it's antenna B, but sometimes it's antenna A. Here's good, that's much better. So whatever happens here, no drops, even the level is low, because both antennas are working well, they are on the same level, and the receiver can detect bits and bytes in the one or the other stream and put this together to merge this together to a perfect audio signal. Yeah, let's go down and jump to some more channels. Yeah, if you see here, yeah, this is good. Antenna level is not perfect, but both antenna playing the part well. And then you go to another signal and you see antenna level is low. One antenna drops to 0, even both antennas drop to 0 sometimes, and you have some audio drops. So let's jump in and see what we see. If we zoom in a little bit, yeah, here you see one antenna is going down to 20, the other antenna is going to 0. Not enough signal noise ratio. Yeah, so the phase change we're using QPSK as a modulation in the Sony system. The phase change cannot be detected because the signal noise ratio is not good enough. That's the same for any information, even in an audio signal. If the noise is very high, you can't understand what the person on the other side tell you if the noise in the environment is high enough. And here, this is the same thing. So the minimum you need is 20 dB, better 25, I would say. Then you're on the safe side. Technical is 20, but I would say from my personal experience it's 25. Which is better than the analog system. An analog system needs up to 40. So that's okay. But you have to take care, what is your noise and where is your signal? And of course, best is for both antennas. Yeah, if you have one, then you can have still some multipass problems with one antenna, but if you have both, then the diversity receivers doing the job very well. Yeah, let's zoom in again, or let's zoom out again and see what we have. That's all okay. And going down, yeah, some more channels. Yeah, here you see nothing. There's some spikes. That's interesting that you have some noise over time. Yeah, that's what happens if you have other systems around you, or if you have some intermodulations coming from other systems. So I don't know if there's some analog intermonitoring in place or so. I have no idea. But you can see this here. This is very, very nice to see. Let's zoom in on channel number 36. And go over. Yeah, what you see here is that your noise level is around 20 dB. So if your noise level is around 20 dB, then your signal noise ratio with plus 25 means that it has to be minimum 45 dB, which is fine here. It's around between 60 and 50, so that's okay, and that's why it is working. But you have to take care of what is my noise level. If the noise level is too high, switch to another channel. Do a channel scan and switch to another channel, and you see, yeah, it's working well. I don't know if this system is used, even on the situation where it is lower, it's doing the job, that's okay. But everything based on signal noise ratio. Here we have a drop, which is maybe not audible, but both antennas going down to 30. If the noise was in this moment the 20 we saw in the beginning of the recording, then we have only 10 dB signal noise ratio, and the system can't detect bits and bytes. And here you have it. That's another discussion about RF recordings from Wireless Studio from a customer he sends me over, and I would definitely change the antenna position. I would think about the antenna position. I would think about the frequencies. They're using 38 channels. And if I see on the beginning of the show that some channels have some heavy noise, then I would go to a backup channel I have prepared before in the system. And as always, if you like the video, thumbs up. If you don't like the video, thumbs down. That's okay. But write me in the comment field what I can do better and what you'd like to see next time in my videos. Have a nice day. Thanks for watching. Bye.